evening, everyone. You're welcome to another edition of EasyMathsTutor, and you're welcome to my new look. Do you like it? Sure you do. So I want to say Happy Easter. Today is Easter Sunday. It's the day that Jesus Christ rose from the dead. Okay? Now that mathematics, nobody understands that. Okay? That's divine maths. So today we're going to look at some questions, some problems that we're going to tackle. I've not solved them before ever. So we're going to work on them together. The first problem is this, right? A lot of text is on this problem. So we're going to find the value of x. All right? So let's start. Let's start solving it. So these are question 1. The question says x all over x minus 3 is equal to 2x all over 2. And we're supposed to find the value of x. All right? So just take a good look at this. View it. Is it difficult or is it hard? Is it easy? Well, let's find out. Let's see how we can tackle this problem. And I want you to also know that you can solve maths wherever you are, or wherever you do, you can tackle any question. All right? So when you have a question with an equality sign, I think the problem is already half solved because of this equality sign, right? We can play with our numbers, right? So this looks like a fraction. It's in the form of fraction. Then you have the numerator and the denominator. We have a numerator on the right-hand side and the denominator also on the right-hand side. This is the left-hand side, while this is the right-hand side of the equality sign. Then when you see a fraction-looking term or function, what do? You can cross-multiply, okay? You can cross-multiply. So what do? Let's cross-multiply. Cross-multiply means multiplying the denominator on the left-hand side by the numerator on the right-hand side. Then the other cross, multiply the numerator by the denominator on the right-hand side. So that is cross-multiply. All right? Cross-multiply. Good. I think we're progressing. So if we do the first cross multiplication, we have, okay, let's start from the first part. Okay, let's say numerator. We have x times 2, right? X times 2, x times 2. And then the other side, we have x minus 3 times 2x. So we say x minus 3 times what? 2x. All right? So what we do next is we simplify. This will give us what? 2x. While this will expand, right? 2x times x is what? 2x squared. 2x times x is 2x squared. Okay? 2x times x. 2x times x. 2 times x times x. X and x gives us x squared and 2. Isn't that simple? I like it so. So then we have a minus sign here, right? This minus is the twin brother of 3. Minus is the twin brother of 3. So we have minus 3. So we say minus 3 times what? 2x. Give us what? Minus. Okay? 3 times 2, 6 times x. So we have minus 6x, okay? Minus 6x. So what are we going to do? We're going to rearrange. We are going to rearrange the equation. All right? We're going to rearrange this equation. So I like my equation to always be positive or tend towards positive. So I'll move minus 6. Minus 6 looks heavier than 2, right? So it's more negative. So I'm going to move this negative to this other side, giving me what? 6x. When minus jumps over this equality sign, it becomes what? Plus. There's an imaginary plus on this side, okay? Remember, there's also an imaginary plus on every positive number. So we say plus 2x equal to 2x squared. So 6x plus 2x will give us what? 8 what? X equal to 2x squared. 2x squared. So now we have something like this that can easily be simplified. I like to do things the easy way. So let's not complicate ourselves. We'll divide both sides by 2, right? Give us 1 here, gives us 4 here. So we have 4x equal to x squared. All right? Divide both sides by x, okay? Divide both sides by x. This will cancel this out, right? This will cancel this out. Leaving us with 4 equal to x. So our final answer is x equal to 4. Hooray! Was that easy or was that difficult? I think that was easy. Wasn't too hard. Don't stress yourself. Simple, right? Now, this one is a little bit, it's a little bit complex, okay? It's a little bit complex. This one. This is a plus x is equal to 2, right? And 2a plus 2x. 2 raised to power a plus 2 raised to power b is equal to 6, right? Then we have 4a plus 4b, 4 raised to power a plus 4 raised to power b. What will be the value, okay? What will be our value? All right? So now we're going to jump into this question together, okay? Whenever you see a question, I've never done this question before, so we're going to work on this together, all right? So what do we have? A plus b equal to 2. That's our first equation. So let me call this equation 1. That's equation 1. I'll call this equation 2. All right? So from equation 1, right? Let's say b is equal to 2 minus a. b is equal to 2 minus a. Plus a jumped over the equality sign, becoming minus a. All right, so we'll call that equation 2. So let's demarcate this part. We'll call that equation 2. All right, so what happens now? So we'll substitute this function into, sorry, this is equation 3, because we're already given this equation 2. So this will be equation 3, all right? So what does that mean? Immediately, we'll substitute that into equation 2. It works like a simultaneous equation, all right? Simultaneous equation means you have a problem that has 2 unknowns. That's a more complex problem, okay? It's not a simple and straightforward problem. It's a problem that has two unknowns. That's a simultaneous equation. And most of the time, you are given two equations to balance your two unknowns, all right? If it's an equation where you're finding one unknown, you're given one equation with the one unknown, just like our first problem. But our second problem, we're given two unknowns. We're looking for two unknowns, all right? So those two unknowns were given two sets of equations to help us to solve the unknowns, all right? So let's jump right into that. So we're substituting b from equation 3 into equation 2. So what we say 2 raised to power a, right? I'll call this actually a simultaneous exponential equation, all right? It's simultaneous at the same time, it's an exponential because it has powers, all right? So we'll say 2 raised to power a plus 2 raised to power b. b is what? 2 minus a equal to 6. This is my first time of seeing this question. Actually, I stumbled on this question on the streets of YouTube. I think I found it on a pre-math channel. I love to watch questions on YouTube. Okay, it has a calming effect on me. I'm a maths lover, so pardon me, all right? So we're going to expand this. We're going to expand this. So we have 2a plus 2 raised to power 2, okay? According to the laws of indices, this will be 2 raised to power 2 and 2 raised to power, it will be 2 raised to power 2 and 2 raised to power minus a, okay? 2 raised to power bracket 2 minus a will be 2 raised to power 2 bracket 2 raised to power minus a equal to 6, all right? So we're going to break that down further. So we have 2a plus 2 raised to power 2 all over 2 raised to power a equal to 6. Equal to 6. Okay? Now, 2 raised to power minus a is actually following the law, the quotient law. That when a power has a negative sign, it's also a fraction. It's also the inverse of that number, okay? So it will be 1 over 2 raised to power a. 2 raised to power minus a is equal to 1 over 2 raised to power minus a. Say x. Let's choose x, okay? So we're going to do it step by step. We don't rush this kind of problem. You do this problem step by step. So, what do we do? What do we do? I'll put the value of 2 raised to power a as x in this equation. So we'll substitute 2a as x in this part. So what we'll have is what? X, remember? X plus 2 raised to power 2 all over x equal to 6. This is going to be a quadratic equation. All right? So you multiply through by x. Multiply through by x. So we're going to continue on this other side of the board. All right? Let me continue on this side of the board. Okay? Maybe I should stand on this side. Okay? I would like us to take this back so that we can see. So, what do we do? What do we do? We'll multiply through by x. multiply through this equation by x. So if I multiply this by x, what will I have? I'll have x squared. If I multiply here by x, it will cancel out this x, right? It will cancel out this x, giving me what? 2 raised to power 2, okay? If I multiply this side by x, it will give me 6x. The way it's done, or multiply both the left-hand side and the right-hand side by x. So what's our final question? We'll have x squared, move this way, minus 6x plus 2 raised to power 2 is 4. So we have over here a quadratic equation. We have over here a quadratic equation. So looking at this equation, I am seeing that there is no easy solution. There is no easy solution. There is no factor of 4. There are no factors of 4 which you will add to give you minus 6. So we're going to use the almighty formula. It's turning out to be a little bit complex, right? So almighty formula is x equal to minus b plus minus the square root of, are we getting it? B squared minus 4ac all over 2a, right? Now we know that a is the coefficient of the first function, or the coefficient of the function that is x raised to power 2. That coefficient is 1. B is the coefficient of the function of x, and that coefficient is what? Minus 6. While c is the coefficient of the constant, and that coefficient is 4. All right? So plug in this coefficient into this formula. Question is long, but I think it has a solution. Every problem has a solution, all right? So minus b is minus 6, okay? So this minus will make it what? Plus 6. So we have 6 plus minus b squared minus 6 squared is what? 36. 36. Minus 4. 4 times a times c. 4 times a is 1, that's 4. 4 times c is 16. Minus 16 all over 2a. 2a is 1. Right? 2a is 1. So we will say this will be 6 plus minus the square root of 20 all over 2. That's the value of x. The square root of 20 all over 2. So let me simplify this without the calculator. Right? 2 here, 2 goes in 3. Right? 2 here, 2 goes in 2. So we have 3 plus minus root 20 all over 2. 3 plus minus root 20. What is root 20? You know that root 20 is what? 5 times 4 all over 2. Right? So the square root of 5 is not a whole number, and the square root of 4 is 2. So we will have 3 plus minus root 5, 2 root 5 all over 2. This will cancel this, right? Giving us 3 plus minus 1 root 5. That's the value of x. That is the value of x. So, remember that x is what? 2a. X is what? 2a. So what are we going to do? X is 2a, so we will say If x is equal to 2 raised to power a, means it's equal to 3 plus minus root 3, right? 3 plus minus root 3. So how do we get the value of a? It's a single equation, so you can easily get the value of a. So what are we going to do? What are we going to do? We're going to find the log, okay? We're going to find the log. Okay, so now let's leave it like this first. Then we'll get b, right? b. b. 2a, okay? So I need a calculator. Just hold on a second. So we'll say 3 plus the square root of 3 gives us what? This. While 3 minus the square root of 3 gives us what? This other number. Okay? So log okay, so that's that. That's that. So remember, I think there's something else here. Assuming we made b, a, the subject of this formula, a would have been what? Still 2 minus b. All right? And if we went through the same steps, what would have happened? Went through the same steps, what would have happened? We would have still had 2 raised to power b, still being the same thing, 3 plus minus 1 root 3. All right? It would have still been the same thing. Wow, 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 wow. I think we're heading somewhere. This is actually a problem that is like a game, it's like a puzzle. The answer is inside the question. The answer is inside the question. And I'm seeing the answer. I hope you're seeing what I'm saying, right? If we made b equal to 2 minus a, and this was what we got, right? This was the value we got. 2 raised to power a equal to 3 plus minus 3. If we made a equal to 2 minus b, we will still have the same thing, right? It will still be the same process. The same what? Process. And we will still arrive at what? 2 raised to power b equal to 3 plus minus 3. That means that 2 raised to power a is equal to 2 raised to power b. 2 raised to power a is equal to 2 raised to power b. All right? 2 raised to power a is equal to 2 raised to power b. All right? Are we saying that? So that's it. These two are equal, giving us 6. That means it's 3. That means it's what? 3. Approximately 3. Alright? It's approximately 3. They are equal. They are equal. Therefore, if it is 4 raised to power A equal to, therefore 4 raised to power A will be equal to 4 raised to power B. It will also be 4 raised to power B. But the difference will be, what will be the difference? Let's look at it. What will be the difference? The difference will be, right? 2 times 2. The difference will be what? Sorry. 2 raised to power 2A equal to 2 raised to power 2B. Alright? So what would the answer be? That's also another puzzle. Can we separate it? Yes, we can. We can separate this, right? So we have 2 raised to power A into bracket square and 2 raised to power B into another bracket square. Using the law of multiplication of exponential. The law of multiplication of exponential will give us that, right? So we're also having it, also having that, right? So if we say this square plus this square, what will happen? Something is common, right? Something is common. Something is common. Wow. It's equal, right? It's equal. So if it's equal, let's try something else. Let's try something else. If it's equal, let's try something else. Okay? So just look closely at what I'm doing. If it's equal, try something else. If it's equal, or let's move to the other side of the board. You just give me a second. The other side of the board. This is the other side of the board, right? Okay. So now, if 2 raised to power A, if 2 raised to power A is equal to 2 raised to power B, right? Let's assume that 2 raised to power A plus 2 raised to power A will also be B. Now let's assume that this is x plus x, equal to 6. X plus x is equal to 6, all right? So that gives us what? 2x equal to 6. Therefore, x is equal to 3 because we divide 6 by 2 on both sides, right? Now they're telling us 4a. We know it's equal. So 4a plus 4 raised to power b is equal to what? All right? We know that is the same thing as 4a plus 4a. What would that be? That would be 8 raised to power a. All right? 8 raised to power a. And we know that 2 raised to power a is what? X. 2 raised to power a is x. So we have 2 raised to power 3 as a. Okay? 2 raised to power 3 as a. We know we can interchange it. 2 raised to power a raised to power 3. And 2 raised to power a is what? 3. It's what? 3. Remember, we chose that initially. We chose that. We said what? Let 2 raised to power a. Let 2 raised to power a be x. So, and we got to the conclusion here that x is equal to 3. So we will say 3 raised to power 3 is what? 3 raised to power 3 will be what? 27. So, the final postulation of this problem will be 27. And that's my answer. That is my answer. That is my answer. So I don't know if there's any other problem that we need answers to. Is there any other problem that we need answers to? I do not know. So let's look for some other problems. Okay, there's a problem I quickly want to tackle with us right now. Our board is already occupied, so let's move on to our other board. Let's move on to this other board. Don't worry, our next class will actually have music in the background so that we can actually party while we solve problems. You know, when I was in university, when we were studying, we actually used to have like a mini party while studying, okay? There was music in the background, blasting, and people were reading. That was really odd. But that's what we did those days. Okay, now to this side. I want us to do a problem that has to do with trigonometry. Trigonometry has to do with trigonometry. Okay, so now it's finding the values of the trig ratios, cos and the major angles. Okay, cos30, cos60, sin30, and sin60 using an equilateral triangle. Finding the values of these functions using an equilateral triangle. For instance, you find yourself in an examination, all right, and you don't have calculator to calculate certain problems. This is a quick fix of how to get the values of these angles using a simple unit isosceles triangle. Okay, so now this is a triangle of unit length. When I say unit length, I mean we choose 1 unit, okay, of no particular length, so assume that it's 1 unit. We assume that it's 1 unit. So today, for this problem, we're going to take each side of the triangle as 2 units, right? And any triangle that has equal sides is known as an equilateral triangle. Any triangle that has equal sides is known as an equilateral triangle. Okay? So now you're in an examination and you want to find cos 30 or cos 60 or sin 30 or sin 60 and you do not have a calculator. What do you do? What do? You draw an isosceles triangle and measure 2 units on each side. Then you draw a perpendicular. A perpendicular means a straight line which is 90 degrees to its base, okay? 90 degrees to its base. So this straight perpendicular will divide these two to give us 1, 1 on each side, okay? 1, 1 on each side. And remember, for the isosceles triangle, all the angles of this triangle are equal. So we know that the total sum of angles of a triangle is 180 degrees. It's 180 degrees. It's 180 degrees, okay? So as a result of that, each of these angles will be what? 60 degrees. Here will be 60, here will be 60, and here will be 60. And this perpendicular will divide this angle equally to give us 30 degrees on this side and 30 degrees on this side. All right? So let's write that down quickly. So this will be 60 degrees. This will be 60 degrees. This will be 30 degrees. This will be 30 degrees. Remember, this is 90 degrees. It's a right angle triangle, so it's 90 degrees. And then we know what happens to all right angle triangles. There's a theory. There's a theory known as Pythagoras theorem. Pythagoras theorem that we use to solve right angle triangles. And we're going to apply Pythagoras theorem to this problem, all right? So, why are we using it? Because we want to find the value of this side, okay? So using Pythagoras theorem, which states that the square of this side plus the square of this side is equal to what? The square of this side, right? So that will be, let's call this side x. Let's call that side x, okay? So it will be what? 1 square, okay, plus x square equal to 2 square. Therefore, x square will be what? 2 square minus 1 square. Therefore, x will be the square root of 2 square is what? 4 minus 1, which is the square root of what? 3. Therefore, we'll write what? The square root of 3 or root 3 as the value of the other side. Sometimes these questions, you may be asked to give your answers in terms of the root of a number or a fraction. Then that means you cannot even use your calculator, all right? So that's why you need to know how to solve this problem. That's why you need to know how to solve this problem, okay? So, know now that we have the value of all the sides of this triangle, we can easily find cos 30, cos 60, sin 30, and sin 60. Okay? And sin 60. Okay? So what do? It's simple. We know that cos theta or cos of any angle is what? The adjacent all over the hypotenuse. The adjacent all over the hypotenuse. Now the adjacent, we're looking for cos 30, right? This is 30 degrees. This side is 30 degrees, right? So what is the adjacent of 30 degrees? The adjacent of an angle is the side of the triangle that rests on the angle. while the opposite is the side of the triangle that is opposite facing the angle. While the hypotenuse, we all know, is the longest side of that triangle, which joins the adjacent line to the hypotenuse, to the opposite, that joins the adjacent line to the opposite line. All right? So let's continue. So cos30. What are we looking for? We are looking for cos30. 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 We are looking for cos30. Cos30 cos30 is equal to adjacent. The adjacent of this cos30 is what? Root 3. While the hypotenuse is what? 2. So cos30 is root 3 all over 2. Cos30 is root 3 all over 2. Is 3 all over 2. All right? Then cos60. Cos60 is what? Cos60, that is the adjacent all over the hypotenuse. And this is the angle 60. This is also the angle 60. All right? Cos60 is the adjacent. This is the adjacent. The side resting on the angle is 1 all over the hypotenuse. All right? So that will give us what? 1 over 2. Cos60 is 1 over 2. Then we have sine 30 degrees. We know that sine stands for the opposite all over the hypotenuse, right? So the opposite of angle 30 all over the hypotenuse will be what? The opposite of angle 30. The side opposite of angle 30 is what? 1 all over the hypotenuse. All right? So what does that mean? That means that cos60 and sine 30 are equal. Cos60 and sine 30 are equal. So let's look for some other equal angles. So we'll say sine 60 degrees. Sine 60 degrees. Sine 60 is opposite all over hypotenuse. The opposite of 60 is what? Root 3. Is what? Root 3. And the hypotenuse is what? 2. Okay? Now, some other ratios that we can also look for. Some other ratios that we can also look for. You can also look for tan. Okay? I have tan 30 degrees. And we know that the tangent of an angle is opposite over adjacent. The opposite side of the angle all over the adjacent of that angle. So what do? The opposite of tan 30. The opposite is what? 1. Quickly. And the adjacent is what? Root 3. Voila! Root 3. So we got a relationship for tan 30. So now we're looking for tan 60. Tan 60 degrees. Tan 60 degrees is the opposite side of tan of 60 degrees all over the adjacent of 60 degrees. Can you tell me what is the opposite of 60? Can you tell me what's the opposite of 60? That's root 3. So let's write that down quickly. Root 3. And the adjacent is what? 1. Isn't that beautiful? So I so love this. Oopsie, 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 oopsie. So I'm seeing something here. That means tan 30 is the inverse of tan 60. Wow. That means cos 30 is the same thing as sine 60. Wow. That means cos 60 is the same thing as sine 30. Double wow. This is amazing. This is completely amazing. So if you have any questions, feel free to ask EasyMathsTutor. Feel free to ask me any question. These questions are questions I found on the streets of YouTube, and I thought we could tackle them from scratch. So I hope we understood everything that's been taught here. So I've kicked in a full on my videos, my live videos, everyday live videos. So if you're passing through, just make sure you stop at EasyMathsTutor and join us in our evening homework or our early morning prep, or wherever you find me. Just make sure you join me and be part of this beautiful opportunity to grow your knowledge in mathematics and to become a maths lover and to overcome your fear of mathematics. There's nothing to be afraid of in mathematics. Mathematics is the foundation of every subject. Mathematics is the foundation of every life. Yeah, foundation of every life. Okay? Because when you were a microscopic organism, your size was infinitesimal, all right? And now you're growing, you're adding numbers, growing taller, growing bigger, you're adding, okay? So we add in maths, don't we? Yes, we do. Even when you grow, and maybe you start doing your businesses, right? You start doing your businesses, you still have to add. You still have to subtract. You still have to compare. You have to do so much. Wow. So it's really, really interesting, and it's something you can't do without. Maths is something you can't do without. So I implore each and every one of us to take maths seriously and try to be part of the maths initiative that I am bringing for each and every one of us. Try and be part of this initiative, all right? Try and be part of this math initiative that will benefit each and every one of us. We're going to be solving questions on common entrance examinations for those moving from primary education to secondary education. So we're going to be tackling simple questions for that level. We're also going to be tackling questions for primary and nursery. Why? Because we're going to be teaching us about shapes. We're going to be doing arts and crafts. We're going to be creating objects. We're going to be creating so many things, because maths is also building, maths is also creative, maths is also artistic, all right? Maths is musical. Now when you're doing your beats, you're composing your music, you need to count 8 beats, 4 beats, 2 beats, 16 beats, all right? So if you're not mathematical, things are going to be pretty hard. So you can just find a way to embrace the subject, because it's on us. It's all around us. Even Easter, Jesus died on a Friday and he rose on a Monday. That's 3 days. 3 days. If you study the scriptures, there's so much mathematics in the scriptures. God talks so much about numbers. In creation, he took he quantified it as 7 days, though we know it's more than 7 days. It's billions of years it took God to create this world. But in order for us to understand, the timing and not get our minds blown, he said it's 1 day. On the first day, he made heaven and earth. On the second day, he created day and night. On the third day, he created the seas. He created the earth. On the fourth day, he created the animals. On the fifth day, he created the vegetation. On the sixth day, he made man. On the seventh day, he rested. That's numbers. There's nothing you can do about it. You can run away from numbers. The earth was created with numbers. Quantity, size, color, shape, time. That's numbers. You can't run away from numbers. Your heart is beating numbers. Your heart beats numbers. You can't run away from numbers. So the best you can do is to embrace numbers. Embrace it. Let it be part of you. Let it be something that you live with, you ride on, you walk on, you talk on. All right? So it's something I encourage us to embrace and enjoy. Don't get bored with mathematics. Mathematics is not a boring subject at all. Mathematics is the most practical subject you could ever do. Mathematics is coding, mathematics is programming, mathematics is computers, mathematics is automobiles, mathematics is construction, mathematics is design. You can't run away from numbers, all right? For instance, I have 6 pens here, right? 1, 2, 3, 4, 5, 6. 6 markers here. I have 6 markers here. You can't do anything without numbers. It's emptiness. Okay, I can't just say I have markers. The question is, how many markers do you have? I have 6 markers. And then they go further. How many colors do you have? I have 3 colors. Out of each colors, how many colors? How many do you have of each color? I have 3 black markers. Okay? I have 2 blue markers. And I have 1 red marker. All right? So, without mathematics or numbers, everything is meaningless. Mathematics adds meaning to everything that we're doing. Mathematics is all about what we're doing, right? So I encourage you to embrace mathematics. I encourage you to be part of EasyMathsTutor. We're going to be solving problems, not just on common entrance for primary, we're going to be solving problems for junior secondary. The junior secondary examinations that makes them to move from junior secondary to senior secondary. We're going to be solving problems in mathematics, okay? Even if you're a science student or an art student, you still have to go through maths as a compulsory subject. Then we have the senior secondary exam, which is like the tough one. That's the exam that qualifies you to go into the university, okay? And most people are scared. You don't have to be scared. Once you ace your mathematics, you can ace any other subject. So come here and let's work together. In the evenings, we're going to have a 1-hour live session. In the mornings, if there's time, we'll also have 1-hour live session. And then along the line, we're also going to solve problems on that too. We're going to have book reviews too. We're going to have some comedy skits. We're going to be having some dramas. We're going to be having some maths vlog. And so many things. There's so much in mathematics. There's so much in mathematics. It's exciting. It gave my life in mathematics, all right? So I think you can do that to you too. I hope you enjoyed this session. I have 5 minutes because it's a 1-hour class. maybe by tomorrow, we're going to have a class that will have more problems to solve in our class tomorrow. So come prepared and make sure when you come to this class, you get your writing materials, make sure you get your paper, make sure you get your pen, make sure you get your calculator. You get your calculator, we'll solve our problems together. I could also give you exercises, homeworks, and assignments to solve also. So that'll make you better in mathematics, less scared of mathematics. Shock your parents, shock your teachers, shock your husband. If you're a mom, you can learn maths. So when your kids come and say, let's do this homework, you'll not be like, what am I doing? How am I going to do this? Just join EasyMathsTutor and become a mathsmom, okay? Become a mathsmom. If you're a dad, don't need to be ashamed when your parents come, when your kids bring problems for you to solve. Join EasyMathsTutor and let's solve those problems together. Let's be successful in mathematics. There's no need to be ashamed, there's no need to hate maths. There's no need to be scared of maths. There's nothing to be afraid of, okay? So hopefully our next live class we will solve questions, and then within the week we're going to do a creative class where we're going to build some solid shapes using our paper, using our measuring devices, our measuring instruments like our ruler. We need the paper, we need a ruler, we need the scissors, we need your pencil, we need your glue. All right, so we're going to make some lovely shapes. We're going to make a village of shapes. All right, make a circle, we're making a cube, we're making a cuboid, we're making a prism, we're making a pyramid. Okay, so we're going to be constructing, we're going to be building, and I know it's going to be fun for each and every one of you. Okay, so there's so many topics that we're going to take care of in EasyMathsTutor. We're going to teach fractions, we're teaching fractions, we're teaching addition, odd mass operations, mathematical operations, addition, subtraction, multiplication, division, brackets. All right, we're going to be teaching so many topics, so many topics. We're going to be teaching sorts, we can be teaching exponentials, indices, logarithms. We're going to teach geometry, trigonometry, geometry like circles, triangles, squares, rectangles, trapeziums, parallelograms. They're not difficult at all. We're going to be teaching angles, that's trig, partly trig, because we have types of angles and how they play around. We have the alternate angles, we have the opposite angles, we have the adjacent angles, we have the alternating angles. There's so many angles, types of angles that play out when lines come together. Okay, and sometimes those angles can be equal when you see them from far. You know, this angle is equal to this angle. It's easy, math is sweet. Then we have calculus, simple calculus, the introductory part of calculus, like differentiation, integration. Now we're going to be learn how to plot our graphs, how to find out gradients of our graphs, how to relate our graphs with our equations, such as our linear equations, our linear graphs, our quadratic equations, our simultaneous equations, our polynomial equations. We're going to be linking all this to our graph plotting, all right? And then there's some other topics. There's so many topics. There's profit and loss, there's percentages, there's interest, common interest problems. There's so many problems we are going to solve. So I want you to just sit back, relax, enjoy mathematics, and to our returning subscribers that keep coming back every day to watch our content, I want to say thank you. And if you're new, this is your first time, I also want to say welcome. And don't stop coming, don't stop don't stop loving maths, don't stop conquering, don't stop being a winner, being the best in your world. God bless you. Take care of yourself. Bye.